Why is adding salt essential for secure password storage? Imagine trying to hide a secret message in a crowded room. If everyone uses the same hiding spot, it becomes easy for someone to find and decode it. That's what happens when passwords are stored without salt. When you store passwords in a database, you want to make sure they stay safe even if someone gains access. Adding salt is like giving each password its own unique hiding spot. It's a random value generated for each password before hashing. When you combine this salt with the password and then hash it, the result is unique even if two users pick the same password. This means that if two users choose the same password, their stored hashes will look completely different. This prevents attackers from seeing patterns that reveal reused passwords. Rainbow table attacks are a common way hackers crack password hashes. These are pre-computed lists of hashes for common passwords. If your system doesn't use salt, attackers can quickly look up the hash and find the password. But when you add a salt, it changes the hash output for each password. Attackers would have to recompute their rainbow tables for every unique salt, which takes a lot more time and effort. It's like trying to crack a code that keeps changing every time you think you have it figured out. Adding salt also makes brute force attacks less effective. Since each password hash is different, attackers can't just run one attack on all hashes at once. They have to attack each one separately, which takes more time and resources. This slows down their progress and makes it less likely they will succeed. Generating a good salt is important. It should come from a cryptographically secure random number generator to be unpredictable. Usually, a salt should be at least 16 bytes long, which is enough to make each salt unique and hard to guess. The salt is stored along with the hash in your database because it's not secret. Its purpose is to ensure each password hash is unique, not to hide the salt itself. When a user creates or updates a password, your backend system generates a new salt, combines it with the password, and then hashes it using a strong algorithm like bcrypt, Argon2, or SHA-256 with key stretching. Key stretching makes the hashing process slower, which is good because it makes cracking passwords more difficult. During login, your system retrieves the stored salt, combines it with the entered password, hashes it again, and compares it to the stored hash. If they match, the password is correct. In the end, adding salt is a simple but powerful step to protect user passwords. It makes each hash unique and resistant to pre-computed attacks. This practice is a key part of backend security best practices for password storage. It helps keep user data safe and secure, even if your database is compromised.